Hi guys. In the last video we left off at what is a group and what are the rules that a group elements will follow. And now what we have to do is move forward from it, right? We have to go to something called group actions. Okay. So we have a rectangle with the corners labeled 1, 2, 3, and 4. And we have a group. It has 4 elements or actions. E, which does no action. H, which does a flip around the vertical axis, also known as a horizontal flip. A V, which does a flip around the horizontal axis, also known as a vertical flip. And R is a 180-degree rotation, right? So this is a rectangle. If we apply E to it, it takes no action. So E keeps it in the same position. If you consider this position A, configuration A, E keeps it at configuration A. What H does is it imagines an imaginary vertical axis passing through the center of the rectangle, and it just flips it. Okay. So H does this. It just flips it. So 2 and 3 come here, 1 and 4 come here, and we get a position B as a result of a horizontal flip. Vertical flip, V, it does the same thing vertically, which means it imagines a horizontal axis and it just flips it, right? So 1 and 2 will come down here, and 4 and 3 will come here. Last but not the least, a 180-degree rotation. So what happens here? 180-degree rotation, which means we take any corner and rotate by 180 degrees. So 2, 90, 90. So 2 comes here, right? 2 comes here. Now all you have to do is to follow the sequence in the clockwise order. So after 2 clockwise comes 3. After 3 clockwise comes 4. After 4 clockwise comes 1. So we get this configuration. So vertical flip gives us this configuration. We name it C. And a 180-degree rotation gives us this configuration. We name it D. Okay. Now we have something interesting to study here. We have position B, which has been achieved by a horizontal flip. What if we apply a vertical flip to this? What if we apply a vertical flip to B? How do we do a vertical flip? We do a vertical flip by imagining a horizontal axis. So 1 and 2 come down, 1 and 2 comes down, 3 and 4 comes up. So basically, as a result of a vertical flip, B goes to D, right? Next, what if we apply a horizontal flip to C? So how do we do a horizontal flip? We imagine a vertical axis and we just flip it, right? We just flip it. So 1 and 4 comes to the right, 2 and 3 comes to the left, and we get D. So we get D from C using a horizontal flip. Basically, this means that this action R gives us D, and D can also be got from A using a composition of or a sequence of actions. Either you can have a horizontal flip followed by a vertical flip, or you can have a vertical flip followed by a horizontal flip. In other words, R is equal to HV is equal to VH. Okay. So the same thing has been spoken in this slide. I'll just move my webcam to the other side so that you can read what is written. The blue line, which means, 1 second. The blue line, which means this line, oops. The blue line, which means this line, is represents a vertical flip. Sorry, it represents a horizontal flip H. The red line represents a vertical flip. And from this configuration E, we get to this configuration using a vertical flip. And the same happens on the right. And the red line indicates a vertical flip, that is a flip across the horizontal axis, passing through the center. And the 180-degree rotation can be got by a horizontal flip followed by a vertical flip, or by a vertical flip followed by a horizontal flip. In group theoretic notation, R equal to HV equal to VH. Okay. So the group of actions, the group of actions, it's the set E, A, H, V, and R forms a group under the composition of actions, and it has the following properties. A V twice, or rather a vertical flip twice, leads to the initial position. A horizontal flip twice leads us back to the initial position. VH is equal to HV, or a vertical flip followed by a horizontal flip is equal to a horizontal flip followed by a vertical flip, and both are equal to a rotation around the axis by 180 degrees. And any of the configuration of the numbered rectangles can be reached from any configuration through a sequence of actions from the set E, V, H, and R. And lastly, the name of this group is called the Klein's 4 group. So I think the only thing we have not discussed here is this particular property. This is pretty easy to show. So suppose this is the rectangle. We apply the vertical flip, which is around the horizontal axis. We get the following configuration. And again, we apply V. We get back configuration 1. So that's basically what it's trying to say. VV is equal to E, because E does no action at all. E just keeps the configuration the same. And applying vertical flip twice also does the same thing. Similarly, 2 horizontal flips will also result in no action. So that's what it's trying to say. Okay, before we discuss this, we have to discuss one more thing, and that is the group of symmetries of a rectangle. Group of symmetries of a rectangle, right? Symmetries of a rectangle. We consider a rectangle like this. 1, 2, 3, 4 are the labels of its corners. And we try to find out what other configuration can be achieved by what are the possible actions that can lead to a separate configuration. And those are basically the symmetries. A symmetry is what? A symmetry is that property of the rectangle which preserves the configuration it is presently in, even after the result of an action. So let's see what a rotation by 90 degree does to it. Rotation by 90 degree, say we represent by R, it will take 2 down here and just follow the clockwise. Rotation by 90 degree is anti-clockwise. So a rotation by 90 degrees anti-clockwise, so the 2 would move here. So the 2 comes here, and you just rotate and you just check the sequence in the anti-clockwise direction. 1 follows 2 in the anti-clockwise direction. 4 follows 1, and 3 follows 4. So this is what you get. Similarly, a rotation, double rotation, will give us 1, 2. This is, so 2 comes to the place 4 is currently in. Now just follow the sequence. 1 follows 2, 4 follows 1, and 3 follows 4. Okay, 3 rotations in a sequence, R. So 1, 2, 3. That's the present position of 2. Just follow the sequence of labels now. 2 follow the 1 follows 2, 4 follows 1, and 3 follows 4. Okay. Next, we have say another action, say F. F is what? F is a vertical flip. We define F to be the vertical flip of this particular group. So a vertical flip is what? We take the horizontal, we take the horizontal axis and we just flip it, right? So 1 and 2, side 1 and 2 comes here, and 4 and 3 comes here. Now we just compose, we do a composition using the same three actions we discussed before, R square, and R cube. In other words, R, and RRR. So we do an R followed by a horizontal flip. Now R followed by a horizontal flip to this configuration. R to this configuration brings us here. So we just have to apply a horizontal flip to this action, to this configuration. So 2 and 3 are at the top. We get 2 and 3 at the bottom, and 1 and 4 are at the top, are at the bottom, which goes to the top. Next, next action would be RRF, which means R followed by an R followed by an F. What would be the configuration? R followed by an R would take it to this one. So just apply a vertical flip. If we just apply a vertical flip, it gets to this one. Lastly, R followed by an R followed by an R followed by an F would be just a vertical flip of this configuration. So 4 and 1 are at the top, so we get 4 and 1 at the bottom here. 3 and 2 are at the top, so 3 and 2 come to the top. So these are the possible, and the other, obviously the action E does no action on the group, on the object, so it just keeps it at the same position. So these are the 8 symmetries of the rectangle. In other words, these are the 8 actions which change the configuration of any particular configuration. The group, the action E, the action R, the action R cube, the action F, which is the vertical flip, the action RF, which is the rotation around 90 degrees followed by the vertical flip, the action RRF, and the action RRRF. So these are the 8 symmetries, and these 8 symmetries form a group. So these 8 symmetries are R, RR, RRR, F, RF, RRF, and RRRF. These are the 8 symmetries. We will be using this group. This is a group, by the way. This is the symmetry, group of symmetries of a rectangle, and we'll be using this group in our succeeding discussions.